Something big happened in March 2026. NASA stood up in front of the whole world and made an announcement. On the surface, it looked like a plan to go back to the moon. And yes, that alone is exciting enough to make your heart beat faster. But if you look a little deeper, you will find something even more important. NASA itself has changed. The old NASA is gone. A new NASA has arrived. And this new NASA has one goal that it will not walk away from. America is going to build a permanent base on the moon. Not visit it. Not take a few photos and come back. Live there. Stay there. And never leave again. This is the story of exactly how they are going to do it. For a long time, NASA moved very slowly. They made promises. They set deadlines. Then they missed those deadlines. Then they set new ones. Billions of dollars were spent. Years went by. And the moon stayed exactly where it was, 384,000 kilometers away, untouched, waiting. People got tired of waiting. Taxpayers got angry. Scientists got frustrated. And somewhere on the other side of the world, China was watching all of this very carefully. China is not just interested in the moon. China wants the moon. They have a clear, detailed plan to land their own astronauts on the lunar surface. They want to find water. They want to find minerals. They want to set up their own base. And they are moving fast. This is not the space race of the 1960s where two countries were competing to plant a flag and shake hands for the cameras. This time, the race is about something that lasts forever. Whoever builds the first permanent base on the moon gets to decide who lives there, who mines there, and who makes the rules. America looked at this situation and made a decision. Good enough is no longer good enough. When Jared Isaacman, the new NASA administrator, walked on stage at NASA headquarters in Washington, D.C., there was one single word on the screen behind him. That word was ignition. It was not an accident. It was a message. The engines are starting. The old way of doing things is over. A new chapter is beginning. Isaacman was direct. He said NASA had been spread too thin for too long. The agency had tried to make everyone happy, politicians, scientists, contractors, international partners, and in doing so, it had accomplished very little. The result was wasted money, wasted time, and a space program that had lost its fire. That was about to change. Before we talk about the new plan, we need to understand why the old one was failing. The original Artemis program wanted to send astronauts back to the moon in steps. Artemis 1 was an uncrewed test flight. Artemis 2 was going to carry a crew around the moon without landing. And then Artemis 3 was supposed to land people on the moon for the first time since 1972. It sounds clean and simple. But there was a massive problem hiding underneath. Artemis 3 was planning to land on the moon using a completely new vehicle, the Human Landing System, or HLS, that had never been tested with a crew. Not once. Going from a basic crew test flight directly to landing on the moon in an untested vehicle was an enormous risk. If something went wrong up there, hundreds of thousands of kilometers from Earth, there would be nothing anyone could do. Because of this, the launch date for Artemis 3 kept getting pushed back. 2024, then 2025. Then 2026. Every year, the same story. The can got kicked further down the road. The moon stayed out of reach. The new NASA looked at this mess and did something radical. It threw out the old schedule and started fresh. Under the new direction, Artemis 3 is no longer a moon landing. Instead, it becomes something smarter, a dress rehearsal. The crew will launch on the Orion spacecraft, just like before. But instead of flying all the way to the moon and attempting a landing, they will stay in low Earth orbit. Once there, the lander vehicle will meet them in space. The crew will dock with it. They will climb inside. They will test everything, the life support system, the communications, the engines, the air supply. They will test the new lunar spacesuits inside the lander's airlock for the first time. If something doesn't work, they are still close to Earth. Problems can be fixed. Lives can be saved. Now, which lander will they use? This is where things get very interesting. For years, everyone assumed the lander would be a lunar version of the SpaceX Starship. SpaceX won a contract in 2022, and they have been working hard. But now, Blue Origin is back in the race. Their vehicle is called the Blue Moon Lander, and it is a serious competitor. NASA has made it clear that it does not matter who built the vehicle first or who signed the contract first. What matters is who gets the job done in time. The first company to have a tested, ready vehicle will be the one that sends American astronauts to the moon. That is a powerful message. Even the biggest names in the space industry are on notice. The deadline for Artemis 3 is 2027. Once the lander is proven in low Earth orbit, the winning company will have only a few months to test it in an uncrewed moon landing, no crew, just the vehicle landing on the lunar surface by itself. After that, they must finalize the design and be ready for Artemis 4. Artemis 4 is scheduled for early 2028. This is when America returns to the moon with humans on board for the first time in more than 50 years. The landing zone will be the South Pole region of the moon, a place that scientists have wanted to explore for a very long time because of what is believed to be hiding there. Then, before the end of 2028, comes Artemis 5. 2 moon landings in the same year. That might sound impossibly ambitious. But this is exactly how NASA used to operate in its golden era. The time between the first moon landing in July 1969 and the second moon landing in November 1969 was just 120 days. NASA did this while using 1960s technology. With everything they have today, 2 landings in 1 year is not just possible, it is the new standard. From Artemis 5 onward, the plan is to send a crew to the moon every 6 months without stopping. America will never give up the moon again. One of the biggest changes in the new plan is the removal of the Lunar Gateway. The Gateway was a space station that was going to orbit the moon. Astronauts would stop there on their way to the surface. It was a key part of the original Artemis plan, and billions had already been spent developing hardware for it. That station is cancelled. But here is the clever part, nothing that was built for the Gateway will go to waste. All of the hardware, all of the modules that were designed for a floating space station, are being redesigned and repurposed. They will form the foundation of the first surface base on the moon instead. A space station that was going to float in orbit will now sit on solid ground at the lunar South Pole. The construction of this base has a budget of $20 billion. It will be built over 7 years. And it is divided into 3 clear phases. Phase 1 is all about setting a high tempo. NASA is not going to tiptoe onto the moon. They are going to arrive with energy and speed and not slow down. In the first 3 years, NASA plans to send 25 missions toward the moon. 21 of those will be actual lunar landings. 2 of those will carry human crews. The rest will deliver technology, equipment, and experiments. The first major challenge that Phase 1 will tackle is power. The moon's day and night cycle is completely different from Earth's. On the moon, 2 full weeks of sunlight are followed by 2 full weeks of complete darkness. During those dark weeks, the temperature on the lunar surface drops to below -200 degrees Celsius. At that temperature, electronics do not just stop working, they freeze solid and break forever. Solar panels are useless when there is no sun. NASA's answer to this is nuclear energy. Specifically, they will use something called radioisotope thermal generators. These are devices that contain a small amount of radioactive material, usually plutonium. As the material slowly decays, it naturally releases heat. That heat can be captured and converted into electricity. No sunlight needed. No batteries that run out. Just a steady, reliable source of warmth and power, day and night, for years. Phase 1 will also introduce one of the most creative new ideas in the whole plan, rocket drones. NASA calls them moonfall drones, and they are unlike anything that has flown before. Each drone is based on the Ingenuity helicopter that flew on Mars, but instead of spinning propellers, it uses small rocket thrusters to hop across the lunar surface. In a single hop, a moonfall drone can travel up to 50 kilometers and stay in flight for 150 seconds. These drones will be sent to explore places that are too dangerous or too difficult for rovers to reach, the edges of deep craters, the tops of high ridges, the permanently shadowed valleys where sunlight never touches. Phase 1 will also finally deliver the Viper rover to the Moon. Viper has been built and tested for years, but it has been waiting for a ride. In 2027, it will launch on a Blue Origin lander and arrive at the South Pole. Its mission is to search the surface for water ice and other materials like hydrogen, oxygen, and rare earth metals. This is not exploration for its own sake. NASA calls it lunar prospecting. Viper is going to map exactly where the resources are, so that later missions know precisely where to dig and where to build. Joining Viper on the surface will be 2 lunar terrain vehicles, essentially cars for the Moon. One will be driven by astronauts. The other will drive itself. Each vehicle can travel up to 900 kilometers across the lunar surface, making it possible to explore a massive area around the base site. And watching all of this from above will be a new network of lunar communications satellites. These satellites will circle the Moon and provide a continuous data connection between the lunar surface and Earth. The connection speed will be 500 megabytes per second. That is fast enough to live stream video in high quality. Every drone, every rover, every vehicle will be equipped with high-quality cameras. And all of that footage will be streamed back to Earth for anyone in the world to watch, live, at any time. The Moon will not be a distant scientific mystery anymore. It will be on your screen. Phase 2 is where the construction truly begins. Between 2029 and 2032, NASA will carry out 27 launches and 24 landings. The focus shifts from exploration to infrastructure. The Moon is no longer just a destination. It is a building site. During this phase, 6 new rovers will arrive on the surface. These are not exploration rovers. They are work machines. Some will excavate rock. Some will level ground. Some will dig trenches for power cables and pipes. The lunar South Pole is going to be transformed, slowly but steadily, into something that begins to look like a construction zone. One of the most exciting additions in Phase 2 is a pressurized mobile habitat developed by Japan's space agency in partnership with Toyota. This vehicle weighs 15,000 kilograms and is essentially a moving apartment. Astronauts inside it do not need space suits. They can sit, sleep, eat, and work in a comfortable shirt-sleeve environment. The vehicle can travel at 3.5 kilometers per hour and is designed to operate for up to 150 hours straight in total darkness. It has a planned lifespan of 10 years. Astronauts will be able to drive it far from the base, spend days or weeks exploring, and then return. It is freedom on the Moon. Power will also be dramatically expanded during Phase 2. Solar panels mounted on tall poles will capture as much sunlight as possible during the bright lunar weeks and store energy in large battery systems. But solar alone is not enough for a growing base. So NASA will also deploy actual nuclear fission reactors on the Moon. These reactors will generate hundreds of watts of electricity and supply power to multiple systems at the same time: habitats, equipment, communications, heating. The base will never go dark. By the end of Phase 2, everything will be in place. Power, shelter, transportation, communication. The Moon will be ready for people to live on it for longer than just a few days. Phase 3 is the moment everything has been building toward. Starting in 2033, human beings will live permanently on the Moon. The Artemis moon base will house a rotating crew of 4 people. Each crew will stay for 28 days at a time, for full weeks on the lunar surface, before returning to Earth and being replaced by the next team. The base itself will consist of multiple connected habitat modules, similar in concept to the International Space Station, but built on the ground rather than floating in orbit. It will be a real home. Not a temporary outpost. A real, functioning home on another world. Every month, approximately 8,000 kilograms of supplies will be delivered to the base. Food, water, air, spare parts, new equipment. The supply chain will be as regular and dependable as any delivery system on Earth. Outside the base, astronauts will begin doing something that has never been done on the Moon before, harvesting local resources. NASA calls this in situ resource utilization, which is a technical phrase for a very practical idea: use what is already there. In the permanently shadowed craters near the South Pole, there is water ice. Robots will drill into these craters, extract the ice, and melt it. That water will be used for drinking and for growing food. It will also be split into its two components, hydrogen and oxygen. The oxygen will supply the base with air to breathe. The hydrogen will be used as fuel for rockets and vehicles. The Moon will start supplying its own resources. NASA will also begin 3D printing on the Moon. The surface of the Moon is covered in a fine dust called regolith. This dust can be melted down and used like cement. Robots will take this material and print it into solid structures, walls, floors, shelters. The first genuinely permanent buildings on the Moon will not be shipped from Earth. They will be made from the Moon itself. NASA has not pretended this will be easy. They have openly admitted that what they are trying to do is nearly impossible. The temperatures, the radiation, the isolation, the technical challenges, all of it together represents one of the hardest things any group of humans has ever attempted. But that is the whole point. The real objective of the Artemis moon base is not just to build a base. It is to show the next generation of young scientists and engineers what is possible. It is to wake up the imagination of every young person who looks up at the night sky and wonders what is out there. If NASA builds a base on the Moon, those young people will grow up believing that genuinely impossible things can be achieved. And they will go out into the world and achieve them. China is ready to do hard things. China is ready to do nearly impossible things. America must be ready for the same. The stakes of this new space race are not just flags and footprints and national pride. The stakes are the future of human civilization beyond Earth. And for the first time in a very long time, NASA is playing to win. The Moon is waiting. And America is on its way, not to visit, but to stay.